Hey everyone, I'm Khandelwal and I welcome you all to Simplilearn's YouTube channel. Today we will talk about LINQ and Lambda Expression. But before we begin, let me tell you guys we have daily updates on multiple technologies. So if you are a tech geek in a continuous hunt for the latest technological advancements, then consider getting subscribed to our YouTube channel and don't forget to hit the bell icon to never miss an update on Simplilearn. So now, without any further ado, let's get started with the agenda for today's session. We will begin our session with a discussion on LINQ. Then we will discuss the lambda expression and async lambda. After that, we will look into the lambda in the standard query operators with an implementation. Now we will dive into the type interface. Then we will discuss the variable scope. After that, we will have a look at the expression tree and expression statements. Finally, we will wind up this session with a conclusion. Now, let's get started with LINQ. LINQ is an abbreviation for Language Integrated Query. Microsoft Query Language is completely integrated and allows for simple data access from in-memory objects, databases, XML documents, and many other sources. LINQ unifies queries in C# and Visual Basic through series of extensions. Next up, let's discuss Lambda Expression. Lambda expressions are the executable components of LINQ equations that translate logic to send to the data source at runtime. Here's the basic schema for Lambda expression. Next, async lambda, a lambda expression that uses the async keyword to integrate asynchronous processing. Here's the syntax to print Simplilearn using asynchronous programming. Now, let's implement this in the code editor. Let's get started. So, using system, then using system dot collection dot generics. We will also using system dot LINQ and using system dot text. Now namespace lambda x, then curly braces, and inside that we will have a class program. Curly braces. Then I will declare a delegate int delag int I. Then we will have static void main string args, again curly braces, and in this we will have delag with my delag is equals to a equals to greater than, to make an arrow, a star a. then int x is equals to my till x with the value, let's say 7. Now let's use console dot write line and print out x. Then console dot read line. Basically, this function will be printing out the square for the 7. So basically it should print out 49. Let's save it and run. As you can see, it is printing 49. Let's get back to our slides. Now let's discuss lambda in standard query operators. A lambda expression with a query operator is evaluated on demand and operates on each element in the input sequence rather than the entire sequence. A lambda expression allows developers to insert their own logic into the usual query operator. Let's take a look at an example. In a code editor where the developer utilized the where operator to recover the odd items from a provided list using a lambda expression. Let's go to the code editor. Let's write a code to get an average of the odd Fibonacci numbers in the series. So we will start with introducing using system, then using system dot collection dot generics. Then we have using system dot LINQ. Then we have using system dot text. Another namespace. Let's have lambda x. Then we have a class program, then curly braces. In this we will have static void main string args. Now we will have int braces fib is equals to, in curly braces let's have numbers 1, 1, comma 2, comma 3, comma 5, comma 8, comma 13, comma 21, comma 34. These are some Fibonacci numbers. Now let's declare another variable double average val equals to fib dot where and braces n is equals to greater than n modulo 2 equals to 1 dot average, then let's have a console dot writeLine to print average var, and another console line to read line. Let's save it and run it. As you can see, it is printing 7.333, which is basically the average of these numbers. Now, let's get back to our slides. Now, let's discuss the topic type inference. Type inference is useful in a number of circumstances in C#, and it may be used without explicitly stating the types. In the case of a lambda expression, however, time inference will only function if each type has been provided, as the compiler must be satisfied. The compiler uses type inference to deduce that x is an integer, which it does by inspecting the transformer arguments given below. Now, let's discuss the variable scope in detail. Variables launched within a lambda expression are not supposed to be visible in an outer method according to the several regulations when employing variable scope in a lambda expression. There is also a requirement that a captured variable is not to be a garbage collected unless the delegate addressing it becomes garbage collection eligible. Furthermore, it is against the rule to utilize a return statement within a lambda expression to force the return of an enclosing method. Now, let's try a code to understand this in detail. Let's start with using system, then using system dot collection dot generic, then using system dot LINQ, then again using system dot text. Then I will have a namespace as lambda x. In curly braces, I will have a class program. Then I will declare some delegates, both tell d1 and delegate boolean d2. This d2 will have int I as argument. Next, let's have a class test. Where I will have my d1 delegate as del1 and t2 delegate as del2. Now let's have public void test method function with an argument as int input. In curly braces, let's initialize the delegates with lambda expression. So first int p is equals to 0, then we will have del1 is equals to empty braces equals to greater than p is equals to 10, then return p greater than input. Then we will invoke del2 after test method goes out of the scope. So del2 equals to, in braces, this time we will have x equals to greater than, to make an arrow, curly braces, we will have returned x is equals to p. Then we will close this delegate. Now we will demonstrate the value of p. This time the delegate has not been evoked yet. So we will have console dot writeLine here I will write p is equals to, I will have a placement 0 here for the variable j. Then we will have bool result is equals to del1 then we will write console dot writeLine. Here we will have p is equals to, in curly braces, we will have placement 0, then comma, then we have b is equals to, in curly braces, placement for 1, where these 0 and 1 represent p and bool result. Now let's write static void main string args. Now let's have test, small test is equals to new test with small braces. Here now I will call test.test method for value 5. Now we will prove that the del2 still has copy of local variable p from the test method. So now bool res will be equals to test dot del2 for the value 10. Then we will print out this with console dot writeLine res. Then I will have a console dot read key. Let's save it and run it. As you can see, it is first printing p is equals to 0. Then when we replace it with 10, the p is equals to 10 and it is printing b is true and then again result as true. Let's get back to our slides. Now let's have a look at the expression tree. Lambda expressions are often utilized in expression tree development. An expression tree distributes the code in data structures like a tree, with each node being an expression such as method call or a binary operation such as x less than y. Statement lambdas, which consist of 2 or 3 statements, are also available but are not employed in the creation of expression tree. A return statement must be expressed in a lambda statement. Now, let's implement this in a code editor. Let's start using system then I will use using system dot collection dot generic. Then we will use system dot LINQ. Then using system dot text. This time we will also use using system dot LINQ dot expressions. Now let's have a namespace lambda x as usual. Here we will have a class program. In this we will have a static void main. Where in main we will have string args. Then we will have int src equals to new 3, 8, 4, 6, 2, 10, 19, 2, 4, 8. Now let's have a for each statement where we will have int j in src dot where x is equals to greater than if x is less than equals to 3, then we will return true. Else if x is greater than equals to 7, then also we will return true. Else we will return false. Then we will have console dot writeLine and we will print j. Then we will have another console line dot read line. Basically what we are doing is we have this set and we are only returning the value which are either less than equals to 3 or greater than equals to 7. So the 4, 6 and 4 will be removed and others will be printed. Let's save it and run it. As you can see, it is printing every value except for 4, 6 and 4. Now let's get back to our slides. Let's have a look at the conclusion. A lambda expression can have parameters and return a value. A lambda expression may be used to declare parameters in a variety of ways. There is no need for curly braces in a lambda expression if there is only one statement, but a curly braces and the return value must be returned if there are several statements. A feature called closure allows lambda expressions to access variables that are available outside of lambda expression block. The closure should be used with caution to avoid problems. Any hazardous code cannot be executed within a Lambda expression. Lambda expressions should not be utilized on the left side of the operator. And this was all for today's session. Hope you guys found it informative and helpful. If you liked this session, then like, share and subscribe. If you have any questions, then you can drop them in the comment section below. Thanks for watching and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.